Okay, today we're going to be starting chapter 2. Chapter 2 is based on logic. The reason logic is being introduced here for this chapter in geometry, even though it doesn't seem like you're doing math, the book of geometry is based on logic. It's based on connecting things. So there's a whole chapter that involves the logic. We will cover some of it, not all of it, but we'll cover some of the major points. So we'll start with 2.1, Patterns and Conjectures. So logic is based on different types of reasoning. One of them is called inductive reasoning. Inductive reasoning is the process identifying a pattern based on limited data. Okay, so that's the first vocabulary you need to know. So if I bring up, or if you ever hear inductive reasoning, it means it's pattern based. Conjecture is a guess, but it's an educated guess. So let's start with problem number 1, finding and using a pattern. Look for a pattern. What are the next two terms in the sequence? So the numbers we have are 3, followed by 9, followed by 27, followed by 81. There is a pattern here. Everything's being multiplied by 3. So if I take my term 3 times 3, I get 9. If I multiply 9 times 3, I get 27. If I multiply 27 times 3, I get 81. So if they want the next two terms, I'm going to take this pattern and I'm going to do it twice. I'm going to figure out the next value and then the value after that. So the first value is to take 81 and multiply that times 3. When we multiply that times 3, we're going to get a value of 243. If I continue the sequence, I multiply that number by 3, I'm going to end up with 729. So this would be me using pattern and coming up with a conjecture, which is an educated guess based on the limited data that I have. Okay, moving on to problem 2, making a conjecture. Look at the circles. What conjecture can you make about the number of regions 20 diameters form? So here we got to look at how many pieces we have. Here we have 2 pieces. So we're going to say that there are 2 pieces, so I'll just put 2 on the top. Here I have 4. 1, 2, 3, 4. Now there is a difference. Here, our diameter, we only have 1. 1 has been cut through the circle, the diameter is 1. Here we are using 2, so D is 2. And we start to see patterns. For this one we have 3 lines, 1, 2, 3, so the diameter is 3. How many pieces are there? 6. So the question is, what's going to happen if I cut this by 20 diameters? So I have a circle, and I'm going to have to cut this 20 times. So diameter is going to be 20. So now we look at the information here and look for a pattern and make an educated guess. So for diameter of 1, I get 2 pieces. For a diameter of 2, I get 4 pieces. For a diameter of 3, I get 6 pieces. So notice that really we're just doubling the diameter to get the number of pieces. So that means that if I double 40, I'm going to get a value of 40 pieces, and therefore the answer would be 40. Okay, let's move on to the next problem. Okay, for problem number 3, we first need to understand what is a counterexample. A counterexample is an example showing the statement is false. Okay, so we're always looking for something that makes the statement false. So we'll look at these 3 examples and look for something that would make the statement that it says false. So for problem 3, verify conjecture is false using a counterexample. What is a counterexample for each conjecture? If the name of a month starts with the letter J, it is a summer month. So we're looking at the letter J, and they're saying that only letters that start with J for the month are summer months. Can you think of one example to make it a false statement? The one I can think of is January. January is not a summer month, and it starts with the letter J. So this would be my counterexample. For B, you can connect any 3 points to form a triangle. True, you can take 3 points and form a triangle. but can we figure out a counterexample? Simple. Take 3 points on a straight line, and this is not a triangle, therefore this is my counterexample. For C, when you multiply a number by 2, the product is greater than the original number. So I'll start with 1. My number is 1, and I'm going to multiply that times 2, and I end up with 2. Well, this one works because my number is 1 and the product is larger than the original number, which is a 1, which 2 is greater than 1. Let's try another one. 2 times 2 is 4. This statement is true because the product, which is a 4, is greater than the number, which is the 2 that we started with. But now let's think of a counterexample. -1 times 2 equals -2. On this example, it's saying that -1 has to be greater than the product, which is a -2. But that is not true. So this statement would not work, and that would be my counterexample. So -1 would be one that makes this statement false, and that is my counterexample. Okay, problem number 3 was the last question. This is a very short unit. It's just all based on patterns and counterexamples.